You are already dead. Not you, not yet, but the version of you that boards that ship, the one we're about to talk about, the one that finally achieves it, that breaks through every barrier humanity has ever faced and reaches the actual speed of light, that person never comes home. And the worst part? It's not because anything goes wrong. It's because everything goes perfectly. Stay with me until the end of this video, because I'm going to tell you something that most physics textbooks leave out, something that will completely change how you understand speed, time, and what it actually means to travel through this universe. The answer lands in the final section, and I promise it's worth it. But before we get there, quick question. Where are you watching this right now? Phone in bed, laptop at a desk, TV on the couch? Drop it in the comments. I genuinely want to know, because this is the kind of video that deserves a good screen. Alright, let's go back to the beginning. For almost all of human history, speed was simple. You walked, you rode a horse, eventually you built a boat and let the wind carry you. The fastest humans had ever moved was somewhere around 40 kilometers per hour, and that felt extraordinary. Then we started stacking breakthroughs. Steam engines, propeller planes, jet engines, rockets. In a single century, we went from wooden biplanes to spacecraft escaping the solar system. The Voyager probe, launched in 1977, is now over 24 billion kilometers from Earth, still moving, still transmitting. That's astonishing. That is one of the most impressive things our species has ever done. And it is pathetically, embarrassingly slow. Here's the math. Voyager travels at roughly 17 kilometers per second. To reach Proxima Centauri, the nearest star to our sun, a cosmic next-door neighbor, Voyager would need about 73,000 years. Humanity's greatest technological achievement couldn't reach the nearest star before our current civilization has risen and fallen a dozen times over. So, we think bigger, we dream bigger. Scientists and engineers have spent decades imagining propulsion systems that don't just inch past chemical rockets, but fundamentally rewrite what's possible. Nuclear pulse drives, solar sails, laser arrays pushing paper-thin spacecraft to extraordinary fractions of light speed. And at the top of all those dreams sits one number: c, the speed of light. 299,792,000 kilometers per second. Travel at that speed, and the nearest star is just over 4 years away. Mars is 3 minutes. The moon is a little over a second. You could circle the entire Earth, all 40,000 kilometers of it, 7.5 times in one heartbeat. That's the dream. That's what we've been chasing. So here's the question everyone asks. What if we finally got there? What if after centuries of physics and engineering and human ingenuity, we cracked it? What if we built a ship, or became a signal, or found some method we haven't imagined yet, and we actually hit the speed of light? What happens? Most people imagine it as a victory lap. You point your ship at a star, you hit light speed, and suddenly the galaxy opens up. 4 years to Alpha Centauri, a couple thousand years to cross the Milky Way, fast enough, finally, to actually explore. That's the fantasy. The reality is something else entirely. And to understand it, you need to understand one deeply strange gift that the universe gives to anything moving fast enough. It gives you time. Or rather, it takes time away from everyone else. In 1905, Albert Einstein published a paper that quietly destroyed the intuitive universe. He showed that time is not a fixed river flowing at the same rate for everyone. It is personal. It bends, it stretches and compresses depending on how fast you're moving. The faster you travel, the slower time passes for you, relative to everyone who isn't moving with you. We've tested this. Atomic clocks on fast-moving aircraft tick measurably slower than identical clocks on the ground. GPS satellites have to account for time dilation, or your navigation would drift by kilometers every day. This isn't theory anymore. This is engineering. This is how the world actually works. At low speeds, the effect is tiny, almost nothing. But as you approach the speed of light, it becomes everything. At 90% of light speed, time for you passes at about 44% of normal. A year for you is 2 years for Earth. At 99%, a year for you is 7 years for Earth. At 99.9%, a year for you is 22 years for Earth. At 99.9999%, 179's fraction below light speed, a year for you is over 200 years for Earth. And right at light speed itself, time, from the photon's perspective, doesn't pass at all. A photon emitted from a quasar billions of light years away experiences zero elapsed time between leaving and arriving. Its entire journey, from our perspective spanning billions of years, is, for the photon, completely instantaneous. Now here's where it gets extraordinary and heartbreaking. This means that if you could travel at or very near light speed, you could theoretically cross the entire Milky Way, 100,000 light years, in what feels to you like just a few years. You could reach the Andromeda Galaxy in what feels like a couple of decades. You could, in a single human lifespan of subjective experience, witness corners of the universe that light itself takes billions of years to traverse. That sounds like the loophole. That sounds like the answer. But remember what I said at the beginning. The traveler never comes home. Because here's what relativistic travel actually means in practice. While you are experiencing your few years crossing the galaxy, 100,000 years are passing on Earth. Everyone you knew is gone. Every civilization you belonged to has risen, collapsed, been forgotten, and risen again. The language you spoke is ancient history. The people you loved are not just dead. They are so far in the past that their names have been lost. You arrive. You step out. You've aged a handful of years. And you are 100,000 years in the future. You cannot go back. You can never go back. Not because of any mechanical failure, not because of politics or money or bad luck, but because the universe itself has moved on without you, and it will keep moving on, no matter how fast you run. Relativistic travel isn't a shortcut. It's a one-way door into a future that has no room for you. And it gets worse. Because even this extraordinary, tragic, time-bending form of travel still doesn't solve the real problem, the one nobody talks about, the one that has been quietly growing the entire time we've been having this conversation. While you were dreaming about light speed, the universe was running away. In 1929, Edwin Hubble discovered something that should have broken the internet if the internet had existed. He found that nearly every galaxy we can observe is moving away from us, not drifting, racing. And the farther away a galaxy is, the faster it recedes. Space itself is expanding, not the galaxies moving through space, the space between them stretching, like dots on a balloon being inflated. And here is the part that changes everything. There is no speed limit on how fast space can expand. The rule says nothing can move through space faster than light, but space itself? Space does whatever it wants. Right now, there are galaxies in the observable universe receding from us at 2, 3, 4 times the speed of light, not because they're violating physics, but because the space between us and them is stretching that fast. Any signal we send them will never arrive. Any ship we launch, even at light speed, will never close the gap. They are gone, permanently, causally disconnected from us forever, not because of distance, but because of physics itself. And here's the detail that hits hardest. This isn't stable. The expansion is accelerating. Something, we call it dark energy, which is really just a name we gave to our ignorance, is pushing the universe apart faster and faster every second. Every year, more galaxies slip over the cosmic horizon. Every year, our reachable universe shrinks. 94% of the galaxies in the observable universe are already beyond our reach forever, even if we travel at light speed, even if time dilation gives us a subjective shortcut, even if we throw everything physics permits at this problem. The answer is the same. The universe is running away from us faster than we can run toward it. The traveler who sets out at light speed toward a galaxy on the other side of the universe doesn't arrive. They travel for their entire lifetime, or what feels like it. They cross unimaginable distances, and they watch helplessly as their destination recedes faster than they advance. They end their journey in the dark, surrounded by nothing. Not because they failed, because the universe was always moving the goalposts. So, what do we do with this? Here's what I keep coming back to. We are, right now, living in the most cosmically privileged moment that will ever exist for observers in this universe. The galaxies are still visible, the evidence of the Big Bang is still detectable, the universe is still young enough, close enough, connected enough for us to see its full shape. A trillion years from now, if anything intelligent still exists, they will look out at an empty sky, one galaxy, eternal darkness beyond, no way to know the trillions of worlds once blazed in every direction. The evidence will be gone. But we are here now. We can see it. And within our reach, the local group of galaxies bound together by gravity, never to be torn apart by expansion, there are hundreds of billions of stars, billions of worlds, enough complexity, enough mystery, enough raw wonder to occupy every civilization that ever arises for longer than we can comprehend. The speed of light is not the finish line we never reached. It is the boundary of our home. And what a home it is. The traveler who launches at light speed and vanishes into the dark made a choice. They chose the horizon over the hearth, and there's something beautiful and tragic about that, the same something that drove every explorer who sailed past the edge of the known map. But for those of us who stay, there is still so much left to find. If this cracked something open in how you think about time and space and what it means to go anywhere at all, subscribe. There's so much more of this universe to explore, and I want to do it with you. I'll see you in the next one.